Hi everyone, welcome to Gate ECE channel. I hope you all are doing good. I have an Instagram account as well as a Facebook page and a Facebook group where I'll be uploading frequently notes and practice questions with the solutions. I'll be linking down that in the description box down below. Please go and have a look at it, and if you like it, please follow them. So I will be doing some problems on Z transform today. The problems will be on the video itself. Please pause the video to write down the problem. I recommend writing down the problem and doing it, because when you write it, it is more easier for you to remember rather than just looking at it. So I recommend writing down the problem and then doing it. So the 29th question, the realization of a discrete system is shown. The discrete impulse response of the system is, I'm just going to draw the and this is a system. This is a unit delay. It is delayed by 1 unit, and if I am going to write the equation of y of n, or the equation of the whole system, we will get y of n. Let's see, y of n is actually a sum of these two, right? So y of n is equal to x of n minus 1, and y of n is feedback, and it is multiplied by 2, and then it is coming here, that is added here, and then it is given a delay. So that will be, I'm taking y of n, that is divided by into, that is multiplied by 2, and it is delayed by 1. Okay, now time to take the Z transform. So we have take the Z transform y of z in z raised to minus 1 x of z plus 2 into z raised to minus 1 y of z. Okay, so from here we take the transfer function, which is equal to y of z divided by x of z, which is equal to z raised to minus 1 divided by 1 plus 2 into z raised to minus 1, right? And simplifying, we'll get 1 divided by z plus 2. Okay, now we have to find out h of n. Okay, to find out h of n, so this is a raised to n u of n is actually z divided by z minus a. Here it is given in the form like az plus 1, so we have to have an z above to get the standard form. For that I am going to multiply it by this 1. Instead of 1 I am going to write z into z raised to minus 1 divided by z plus 1, and z raised to minus 1 is kept aside, and z divided by z plus 2. So the inverse of z transform of z divided by z plus minus 1 is a raised to n u of n, that is 2 raised to n u of n, and it is multiplied by z raised to minus 1. It is multiplied by z raised to minus 1 when there is a unit delay. So the overall h of n is equal to n minus 1 u of n minus 1. Actually this is at minus, right? So it is minus of minus 2, that is minus 2 the whole raised to n. Okay, so this is it, the answer. H of n is equal to minus 2 whole raised to n minus 1 u of n minus 1, and have to find out the range of a k value for the system stability, right? So for that I am just going to write the overall h of z of the system, and we will then apply the things we know about the stability of a system in regards to z transform. Okay, first of all we are going to write our h of z, h of z, we can use the Mason's formula, that is g1 of z, this is one forward path divided by this is a feedback path, that is 1 minus g1 of z, negative feedback is, no, sorry, positive feedback is given here, right? That is yeah, this plus minus g1 of z and g2 of z. So we'll get we'll have to simplify it. That is okay. So this is the overall transfer function, that is, I'll just write here, okay. The overall transfer function is equal to z divided by z minus 2 divided by 1 minus k, 1 divided by 1 minus k. So for the system to be stable, the pole magnitude should be less than 1, okay. That is, for a system to be stable, the ROC should include the unit circle, so the pole magnitude should be less than 1. Here the pole is 2 divided by 1 minus k, this should be less than 1, that is 2 divided by 1 minus k should be less than 1. K, that is equal to 2 divided by 1 minus k less than 1 and 2 divided by 1 minus k less than minus 1 too. And we'll get from here you can get k less than minus 1 and k greater than 3. Combining, we will get minus 1 less than k less than, sorry, k greater than 3 and less than minus 1, right? That is 3 less than k less than minus 1. Okay, so this is the answer. With that, I'm going to end this essay transform problems, and we'll see in the next video. Thank you for listening.